Hello guys. So welcome. So right now I'll be doing the second question, which is a number of distinct islands. Uh, so this is you guys might have done number of islands, which is a very similar question, but this is a little bit more complicated. This is a DFS based question. If you guys didn't know, most questions you can solve it with either of them, DFS or BFS. Usually these maze type questions, but generally where you have to do something where you start and you want to get something like this or like this, we usually use DFS over BFS. So I'll show you guys how I usually approach DFS questions and how you can approach them. So in number of islands, how we used to store is when we start here, we go from here, right? So we start our DFS from every possible element as long as it's possible. And if there is a new DFS that is starting, that means you've encountered a new island. So for example, we start here, we go right, we reach here, we try going right again, we don't have any more things. Then from here, we try going top, nothing. We try going bottom, you have this element here. Similarly, so in this DFS, we cover these four elements. Now after this, we start from back from here, then we check this. So now we have updated the number of islands to one. This is already visited from this DFS here. Then you go here, zero, 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 zero. Ha. So now we have encountered a new DFS from the for loop. So this will kickstart the second island. Like that, we can keep going, right? So what this says is that we need to find the number of distinct islands. So a number is so here it's mentioned is you can obviously go four directions, and it's said to be same as an other island if it can be translated. What translated means is that this four and this four basically represents one island. In similarly, in this case, this three and this three are different islands because you cannot exactly transpose this shape to this shape, or you can transpose these two, right? So how are we going to store this? So now obviously we need a type of visited set, but what type of visited set is this? So we'll obviously have to first keep track of all the possible elements that we have visited. So now what we can represent is we can represent it as a shape, right? If you know what I mean, we can represent it as coordinates. So for example, what do we have? What do these two have in common? So suppose this is 0, comma 0, 0, comma 1, 1, comma 0, 1, comma 1. Can this not be the same thing? The only difference in this case is this will be 0, 1, 2, 0, 1, 2, 3. 2, comma 3, 2, comma 4, 2, this is 3, comma 3, comma 3, and 3, comma 4. So this, if you subtract it from the element that you start the DFS in, which is this element, do you not get the same pattern? Give you an example, right? So suppose we have an origin. So in this case, we have origin that we start the DFS from is 0, comma 0. And how do we go? So we have these four elements, which is 0, comma 0. Then you have 0, comma 0. Then you have uh, 0 comma 1, then you have uh, 1 comma 0 and 1 comma 1. So now this is the origin, as you can see, and these are the coordinates. So now in this case, if you subtract each of the coordinates from the origins, what do you get? In this case, we get these elements back, right? So now let's do the same thing for here. So what is the origin here? So in this case, the origin will be 0, 1, 2, 0, 1, 2, 3, right? So it will be 2, comma 3. And what are the four coordinates? So this will obviously be 2, comma 3. Then this will be 2, comma 4. What will this be? This will be 3, comma 3, correct? And this will be 3, comma 4. Now, when we subtract each of these coordinates from the origin, what would you get? Would you not get the same thing back? 0, comma 0. This is how we can represent unique islands. So what we can do is we can store we can store this coordinate set as a combination in a set. So, and we can print the length of the set. So now if we encounter the same one, then we won't add it, obviously. Only if there's a new one, then we'll add, right? So yeah, this is how I'm going to be approaching this question, where we can find the distinct island. Also, the way we'll store a list of coordinates within a set is by converting it to a string. All right, so it'll be easier once I explain it. All right, so let's start. So as usual, before we start any question, let's define the length of the grid and the width of the grid. So n is equal to length of grid 0, right? So now we have m, which is this length, and we have n, which is this length. So remember, let's also keep a visited array, which is a set, and let's keep a length of the distinct islands, which will also be a set. So this will keep track of the distinct islands, and this will keep track of the visited set. So now also let's have a coordinates array. Let's have a coordinates array which will keep track of. You can also pass this as a parameter to the function. I prefer doing it this way. So where we have a global element and we can declare it as a non-local within the function. So now let's define a DFS function which takes both the elements as a coordinate. And remember, we also need the origin point from which we started. I'll add that a bit later. So for now, let's just declare a DFS function. So we have a hypothetical DFS function from here. So now we need to start a DFS from all the possible endpoints. So for I in range n and for j in range n. So we iterate from m and we iterate from n, right? So we're going from both of these points. So now we go from the length and the width, all right? So now what we can do, if I comma j not in visited. So it should not be a visited element. Now, if it's not a visited element, let's redeclare the coordinates array as 0. Let's redeclare the coordinates array as 0. And then after we declare the coordinates array, what we will do is we can move both up and down. So in this case, we'll start the DFS, right? So we first declare the coordinates array. Now, after we declare the coordinates array, we want to run a DFS on I comma j. Remember, but in this case, we also need the origin. So what are we originating from? In this case, we start from 0 comma 0, right? So we originate from I comma j. It'll be more clear. So now the way it will work is we originate from 0 comma 0, and then we'll run the DFS. We'll cover all these elements. Now in the next iteration we come here, we'll run, in this case the origin will change, all right? So we run the DFS in I comma j, and we also have to pass in the origin, since that is very useful. So we pass in the origin as well. So apart from that, now we also have to check, right? Yep. So now we do if str of coordinates, or we can just directly add it. So set keeps only one set of elements, it will not keep a duplicate. So we can do distinct islands dot add str of coordinates. So since you cannot store a list within the set, we convert it to a string and then store it. All right. So now this is the general approach that I use. All right. So now let's do the DFS. And then at the end of it, we can return the length of the distinct islands, which is a set. All right. So now let's start this. So first we'll declare non-local coordinates. Okay, so now once we have this non-local coordinates, well, what this non-local basically does is when you declare something outside functions to keep a constant variable, we'll keep this as non-local. That's the best approach to do it. So now once we have this non-local, we first start. All right. So now let's check if now we also okay. In this case, if it's I and j not in visited and the grid of I comma j should not be equal to 0. Yeah. Alright. So if this case is true, then only we'll do the DFS, right? So now we'll do the DFS. So now how I usually like doing these questions, if you have seen my previous video, is to declare a direction array. In this case, we can go 4 directions, right? Top, left, right, bottom, and top. So let me just declare it. So we have left, we have right, we have top, and we have bottom. So to go left, we can do 0 comma minus 1. So if you have an element here, 0 comma 0, to go left, it will be here, right? So which is 0 comma minus, which is out of bounds, obviously. We can go right, which is here 0 comma 1. We add 0 comma 1. Then we can go top, which is minus 1 comma 0. From any element, if you subtract minus 1 comma 0, you go top. And then we can have 1 comma 0, which is basically going bottom. So now we have this, right? So now non-local coordinates. So now first we only have valid endpoints here, right? So first what we're going to do is we're going to add it to the visited. So visited dot add I comma j. All right. And also remember this, we also have to add it to the coordinates. So what we're going to add to the coordinates, we're going to add the element I comma j, but we also have to subtract it from the origin. Remember that. So since you had in this case, when you have 2 comma minus 3, you have to subtract it and get 0 comma 0. In this case, it's 0 comma 0 and the origin is also 0 comma 0, so you end up with 0 comma 0 anyways. So coordinates dot append. What we're going to append? We're going to append a tuple of I minus origin of 0 and j minus origin of 1. All right. So this is the way we do it. I'll show you guys in the debugger just to make sure. All right. So we add visited I comma j. We have to add that element to the visited, obviously. And now at the end of it, we distinct islands dot add coordinates, right? So we do that. So now what we're going to do is for dx comma dy in direction. So we go through all possible directions from this element. Now first things first, we have to make sure that the element is valid. So we first add a new x is equal to we can keep it as di and dj, right? It will be easier since we're adding it to I. So now we have a new I, which would be I plus di, and a new j, which is equal to uh, j plus dj. So what this will do is basically we have 0 comma 0. We first add 0 comma minus 1. So new I would be 0 plus 0, which is 0. New j will be 0 plus minus 1, which is minus 1. So in this case, new I and new j will be 0 comma minus 1, which will obviously be out of bounds. So we can't go left from here, right? So what we're going to do to check that? Now, if 0 less than equal to new I less than equal to m, which we have declared here, m and n, right? And 0 less than equal to new j less than n. So we have both of these elements. So we have to make sure that the new I and the new j is within bounds. So this condition checks that. And so now once these two conditions are checked, now it is in bound and grid of ij, sorry, new I and new j. So now this is in bound, so you can check new j is not equal to minus 1. It's not equal to 1. So obviously you have to, or not equal to 0. Yeah. So you have to make sure that you're not moving to a 0. Obviously, so you're not moving somewhere beyond that. And we also have to make sure that the new I and the new j are not in visited. And this, yeah. So now if all these conditions are true, only then you want to run a DFS again on the new I and the new j, and also you need to keep track of the origin. So this is how we're going to approach it. And yeah, so if these conditions are true, if it's in bound, then we will run the DFS and the DFS and then we'll run the DFS. I'll just show you guys. I have to first confirm if this works. I'm not exactly sure. There might be a few errors. Oh yeah, it works. So 0, 1 and 3, and let me submit it. Yep, so it works. The efficiency is a little bit low, mainly because I've added a lot of helper functions just to make it clear for you guys. You can actually make this more efficient, but in general, this is an accepted solution. So I'll just show you guys how it works and how you can approach it. So there are other things. I'm not sure if you can, I think you can keep this as, pass this as a coordinates array separately and then add it as well. Instead of declaring it as a non-local function, we can also do it like this, where you can just remove this. Should still work. I'm not exactly sure. I've not done it this way, but yeah, and then we can add it. Not exactly sure if this works. Yeah, you have to put some pass coordinates. No, it works. Okay, yeah, you can do it like this as well. So you can pass it as a separate function within it. just to make it clear, so you guys don't have to use the non-local temp and all that. So yeah, let's see how it works. I'll run it in a debugger just to show you guys the working. Yep. So let me run the first one. Start debugger. Yep. So I obviously start from there. We first get the length and the width. We declare the two sets. We declare the direction. We have the DFS function, which it won't go to for now. We'll start here, which is I in range M00. So yeah, we start with the first element. So it is an island endpoint. So we start here, and it's not a zero element. So we first start the new coordinates. Now we have started a new island. Let's complete the island. And what is the start point of the island? 0, comma 0, right? So now let's go into the function. Let's DFS from this endpoint. So let me just show you guys this way. Yeah. So we have started here, right? So let's run the DFS. So we are going to DFS from here. We're going to go find the island from here, right? So now DFS. Yep. So now what we're going to do, we're going to first keep the coordinates array is initially empty. So we're going to append I minus the origin in this case is 0, comma 0 since we start from there. So what we're going to do is we're going to append 0, comma 0 minus 0, comma 0, which is 0, comma 0, right? So now we add it, we add the 0, comma 0 to the array. And now after that, what we're going to do is we're going to go in all possible directions. So we can go left, we can go right, we can go top, we can go bottom. So now first we go left from here. Where's the debugger? Yeah. So now let's go left. So let's go left from 0, comma 0. New I will be 0, new j will be minus 1. So this will not be a valid endpoint since new j is not within this. So you won't run the DFS. So now let's go for the next direction. The next direction is right. Can you go right from here? Yeah, you can. So you'll go right from there, which is 0, comma 1. So 0, comma 1, you can. So you run a DFS from 0, comma 1. So now 0, comma 1, what will the coordinate be? It will be 0, comma 1 minus 0, comma 0, which is the origin, which will be 0, comma 1, obviously. So the coordinates array so far is this. Mainly it will change when it comes here, which I'll show you guys. So now, yeah, we run here. So now from 0, comma 1, we go left since we start with left, right? So from here we go left, but obviously left is already visited. So new I, comma new j will be 0, comma 0. 0, comma 0 is already in the visited array, so it will not go. So new I, comma new j is not in visited, so it won't go. So now it will go back to the directions array. We have done left. Now we'll go right since the next element is right. So from here we go right. So right will be a 0, so it will not execute further. So 0, comma 2, which is ocean, so it won't go. Now it will try going top. Top will obviously be out of range. It will be minus 1, comma 0, which will be out of minus 1, comma 1, which will be out of range. Now it will try going bottom. Bottom is valid, if you guys can see. DFS, it will go to the DFS because from here we can go bottom. It is still a part of the same island. And now we have gone here, it will append that. So now it will append 1, comma 1. So far we have this in the coordinates array, right? So DF and DJ. So now we are going left from here. So from each element we try going left, then right, then top, then bottom. And as long as it's a valid, it will keep going from there. So now from here we've gone left first, which is now a new valid element. So now you have 1, comma 0. So 1, comma 0 is a valid element. And now we'll go DFS from 1, comma 0. So from here, it will try going again left, then right, then top, then bottom. So in this case, left is out of bounds, right is already visited, top is already visited, bottom is out of bounds. Bottom is a 0. So yeah, so it'll add now 1, comma 0. So we have visited the entire island. So it doesn't look like there's any more possible directions. If there was, suppose there was a 1 over here, after it goes here, it completes all 4 directions, it will come back to this. That's how recursion works. After it's completed all this calls, it will go back here. After it's completed all of this calls, it will go back here. It will check for all the remaining calls. Then it will come here. It will check for the remaining. After that, it will get over. So now new I, comma new j. So you try going left, you can't go anywhere left. Then you try going right, you can't go anywhere right, which is valid. Then you try going left again. which you cannot go anywhere. Now again, now it will keep going back. Now we are back in this, so it will keep running this for all. It will try going to all directions for all of them, and now I'll tell you when it ends, right? So right now we are in 1 comma 1. So after this is done, we check all possible directions from 1 comma 1, which is from here. We have already completed this. Now we are completing this. As you can see, 1 comma 1. After this is done, it will go back to 0 comma 1. Yep, so you're back to 0 comma 1. So now it's already checked bottom of 0 comma 1. So now it will go to left. It will go back to 0 comma 0, if you can see. Yep. Yep, now you're back at 0 comma 0. So you have completed left from 0 comma 0, you have completed right from 0 comma 0. Now what is remaining? Top is remaining and bottom is remaining. As you can see, top is now out of bounds and bottom will already be in the visited array. So we're going top, top is out of bounds, and now we try to go bottom, and bottom is already in the visited array. So yeah, we have completed all four directions from here. So now we'll go back to the for loop, if you can see. So yeah, this is done. Now we're back in the for loop. So now what we have? We have these four in the coordinates and we have a particular shape, right? 0, comma 0, 0, comma 1, 1, comma 1, 1, comma 0. Now once it reaches here, it's going to store the same shape because we are going to subtract the origin from it. So it will store the same shape. So now what we're going to do, we are going to add this shape to the coordinate. We're going to add the shape to the distinct silent. So yeah, so we have added this. Now in the next, when we do these four, what we're going to see, we're going to try to add the same string to this, which is not possible because a set can have only a unique element. If you try to add the same element, it won't be added. So now we're going to keep going right. Yep. So now we check for 0, comma 1. 0, comma 1 is this element which is already visited, so it will not go further. Now we check for 0, comma 2, which is a 0. Then we check for 0, comma 3, which is a 0. Then we check for 0, comma 4, which is a 0. Now we go back to the M loop after that. So the M loop, now we have started from the second row. These two, as you can see, are already in the visited array, so it will not go further. Yep, and the other three in this row are all zeros, so it will not touch. So the next time this DFS will actually be invoked is for a new array, which will start from here. So it will keep going. Now we are in the third row. It will start from 2, comma 3. We are in 2, comma 1. Now we are in 2, comma 2. Now we are in 2, comma 3. So now we have encountered a new one, as you can see. So we reinitialize the coordinates array. We reinitialize the origin. In this case, it's just 2, comma 3. And now we run the DFS from here. So from a new origin, we're running the DFS. So as you can see, now in the first element, you have 2, comma 3 as I and j, and we have the origin as 2, comma 3. So now this shape, what you wanted to store it as? You want to store it as a 0, comma 0, mainly because you wanted to mirror this one, right? So the best way to do that is to just subtract the origin. So the origin is 2, comma 3, I and j is 2 and I and j is 2 and 3. So when you do coordinates dot append I minus origin 0 and j minus origin 1, you get 0, comma 0. See, coordinates array 0, comma 0. Now the exact same thing what happened here will happen here as well. It will try going left, then top, left, then right, then top. No, it will go left, then it will try going right. Yep, you have a right element. Then from here it will try going left, already in the visited. Then it'll try going right out of bounds. Then it'll try going top in the visited. Then it'll try going bottom. Yep. So this is there. So then this will subtract from the origin, right? So 0, 1, 2, 3, 0, 1, 2, 3, 4. So 3, comma 4 minus 2, comma 3. What is that? 1, comma 1. Isn't that the exact same as this? Similarly for this one, this is 2, comma 3, which will be stored as 2, no, so this is 2, comma 4, which will be stored as 2, comma 4 minus 2, comma 3, since the origin is 2, comma 3, so that's 0, comma 1, which is the exact same as that. So that's how we're going to end up storing it. So now if I can just show you guys at the end of each of this, let me just let me just print the coordinates array. So I think this will be an easier way to show you guys. So yeah, so you're going to end up with the same coordinates array. So when you try to store the set it will store it as unique. So let me just show you guys for this one. So now for this one, the distinct islands that you get are 0, 0, 0, 1, and 1, 0. So what is this? 0, 0, 0, 1, and 1, 0. This is a particular shape. So why is this shape different, the fourth one? That is because that is encountered as 0, 0, which is this one. Then this is encountered as a 1 0 and a 1 minus 1. It's a completely different shape. As you can see, even though both of these have three elements, they are stored as different shapes. As you can see, if the shape, these all represent a particular shape, if you know. So that's how we're going to be storing it, and that's why we're doing it as str coordinates. So yeah, this is a very simple question, and in general for BFS DFS questions, we always declare a directions array and then work from there. So yeah, thank you guys so much for watching this video. I'll try uploading more questions whenever possible. So yeah.